Okay, welcome back. So one of the things I wanted to explain is uh, why ratio test is inconclusive if the ratio is 1. Okay, so to view this, let's look at two examples. Let's look at 1 over n and n equals 1 to infinity. It doesn't really matter where it starts, as long as it's after 0. N equals 1 to infinity of 1 over n squared. Okay, so remember this diverges uh, because it's a p-series with p equals 1, and this converges because it's a p-series with p equals 2. Okay, so let's first off remember divergence test. Divergence test says you take the limit as n goes to infinity of the sequence, and in both of these cases, the limit of the sequence is 0. Okay, so if we think about what that means for divergence test, the fact that we got a 0 here and a 0 here means that uh, the test is inconclusive. Okay, if we go to ratio test, take the limit as n goes to infinity of the n plus first term divided by the nth term, take the absolute value. This is the same limit n goes to infinity of n over n plus 1. So this limit is 1. Meanwhile here, take the limit as n goes to infinity of 1 over n plus 1 squared over 1 over n squared, absolute value. This is the limit as n goes to infinity of 1 of n squared over n plus 1 squared. Okay, so now this limit here is also 1. If you want to see why that is, you can use L'Hopital's rule a couple times, or you can factor out an n squared from the numerator and denominator cancel, and you get 1. Okay, so we see in both cases, we know that in both cases we got divergence test tells us inconclusive, and we got ratio test tells us inconclusive. Okay, however, we know the harmonic series diverges and 1 over n squared converges. Thank you.